Welcome to the tutorial how to process Modbus RTU devices with the EASY-COM-RTU-M1 module on an easyE4. In this example, a PowerXL DG1 frequency inverter is connected serially to the EASY-COM-RTU-M1 module. The following technical requirements must be met for this: an EASY-COM-RTU-M1 module, an easyE4 basic device with firmware version greater than or equal to 1.4, including a bus connector for communication modules on the left side. A note: the bus connection plug is included in the scope of delivery of the Modbus module. The EasySoft programming software greater than or equal to version 7.4. A license is required for the EasySoft programming software. Software, firmware and updates can be downloaded from www.eaton.com/software. The exemplary used PowerXL frequency inverter DG1. What does the structure of the exemplary application look like now? The EASY-COM-RTU-M1 module is connected to the terminals 25 and 26 of the PowerXL frequency inverter DG1. If the DG1 is the last device on the Modbus network, the terminating resistor must be switched on. With the easyE4, the terminating resistor is switched on by software. 4 elements are installed in the RMQ Titan surface mount housing. The emergency stop button, the green on button and the red stop button each have a normal open contact element. A potentiometer is installed on the lowest position. A note: the emergency stop switch shown here connected to input I1 of the easyE4 has an indicating function and no safety relevant function. For safety relevant functions, emergency stop switches must operate according to the principle of forced actuation and lead to forced opening of the circuit by means of a normal closed contact element. The easyE4 must not be used to implement safety relevant functions in the sense of personal and machine protection or as a safety relevant control, such as emergency stop. More detailed instructions are given in the Eaton safety manual. In this application example, the green on button on digital input I2 of the easyE4 is used to start the DG1, and the red off button on digital input I3 of the easyE4 is used to stop the DG1 during operation via Modbus RTU. On the PowerXL DG1 variable frequency drive, both analog inputs are assigned to potentiometers. The analog moving coil measuring instrument is connected to analog output 1 and displays the actual output frequency of the DG1. The switching elements of the upper row have a double function. On the one hand, they contain the on switches for the digital inputs DI1 to DI4, shown in bold in circuit diagram. On the other hand, the indicators for the digital output DO1 and the relays RO1, RO2 and RO3. Here the normally open contact is used in each case. The second row contains the on switches for the digital inputs DI5 to DI8. All 8 on switches have a push button function to the left and a latching function to the right. Digital input DI7 is not assigned with any function by factory default. In this application example, the status of the digital input is read in via Modbus RTU and used to write an acyclic value. The STO, save torque off input, is positioned to the left of the 2 potentiometers. In the left position of the switch, the DG1 would coast directly and output the error message save torque off on the keypad. To be able to process an EASY-COM-RTU-M1 module on an easyE4, at least firmware version 1.4 must be selected on the easyE4 basic device. In the extension parameter tab of the Modbus master, the same communication settings must be made for the baud rate, the stop bits and the parity bit as for the connected devices. At the Modbus RTU slave, the correct device address and the byte order big endian have to be set at the extension parameters. The function codes FC3, FC4 and FC16 required for this project for serial communication are to be entered in the cyclic data tab. In the tab Assign operands, the Modbus registers operands are assigned. A note: the easyE4 has no variable declaration for the process input and process output data words. The analog input and output operands are used for this. As an example, in the analog input subregister, register 2102 is assigned to operand IA05, which corresponds to the actual speed of the connected drive. IA06 is the status word. IA07 corresponds to the DC link voltage. This operand is not used in this program. IA08 is used to read the status of digital inputs DI7 and DI8. In the analog output subregister, QA05 assigns the control word to register 2000 and QA06 to the speed reference. Register 2006 and 2007 are not used in this project. A note: both the processed input data word registers, analog inputs on the easyE4, and the process output data word registers, analog outputs on the easyE4, are set with an offset of 1 for communication between the easyE4 and the DG1 frequency inverter. For example, the control word in the easyE4 is registered 2000. In the DG1 is registered 2001. The program of the easyE4 is explained below. In network 1, the control word is assigned to marker word 1. In network 2, the status word is assigned to marker word 2. In network 3, the speed reference is assigned to marker word 3. In network 4, the actual speed is assigned to marker word 4. In network 5, bits 9 and 10 in the control word are used to set the enable for starting and stopping the drive, as well as the setpoint setting via fieldbus. In network 6, marker bit 01 is set for the start via digital hardware input 2, which corresponds to the first bit of the control word. In network 7, marker bit 01 is reset again for the stop via digital hardware input 3. In network 8, the status of digital inputs DI7 and DI8 is read from the drive and assigned to marker word 08. In network 9, the corresponding bit marker 113 from marker word 08 for the status of digital input DI7 is used by the drive to trigger the module for a cyclic setting of the fixed frequency. In network 10, the display change between the different display modules is triggered via the right and left key P03 and P01 and temporarily stored in marker word 10. In network 11, counter CP01 from network 10 is reset to 0 when 65,535 is reached in marker word 10. In the following networks, the marker bits 145 and 146 from marker word 10 are evaluated. If marker bits 145 and 146 are false in network 12, the text display 01 is selected. If only marker 145 is true, the text display 02 is selected in network 13. If only marker 146 is true, the text display 03 is selected in network 14. The control word is displayed in text display 01. The Alt key is used to switch to input mode, and the cursor keys are used to change the reference or the direction of rotation of the DG1 frequency inverter. On the left, the DG1 is started and stopped via the run bit from the control word. In text display 02, the ready, run, fault and direction bits are displayed from the status word of the DG1. Below this, the actual output frequency is displayed in percentage and scaled in hertz. In text display 03, the fixed frequency 1 scaled to hertz is entered via acyclic communication. This value is then written from digital input DI7 of the DG1 frequency inverter via rising edge of the read-in status. Let's move on to the demonstration of the application example. On the external remote touch display EasyRTD, the text display 01 for the control word is displayed because both marker bits 145 and 146 have the state false. On the DG1 frequency inverter, the sources for local and remote mode have been changed. In local mode, the terminal was selected as the command source instead of the keypad, and analog input AI1 was selected as the reference in order to be able to control the DG1 detached from field bus operation for maintenance work, for example. In remote mode, the field bus is the source for the control commands and for the reference. The selection for local/remote operation is made with the digital input DI8. For operation of the DG1 frequency inverter via the serial Modbus RTU interface via terminal 25/26, the digital input DI8 is switched on. This is indicated on the frequency inverter by the remote LED lightening up. In addition, the control flag in the top row changes from I/O to bus. On the external EasyRTD, the reference value is set to 76.3%. The DG1 variable frequency drive is started via the green Start button. This sets marker bit 01 in network 6 of the easyE4 program. A change is made to text display 02 for the status word via the right P key. An external fault is generated via digital input DI3 of the frequency inverter. The red fault LED lights up on the frequency inverter and the left status flag changes from run to NRD for not ready. The error display, external error, is flashing in plain text. On the external EasyRTD, the ready bit goes to false and the fault bit becomes true. When the output frequency reaches 0, the run bit becomes also fault. The reset of the external fault takes place via the digital input DI4. Since the frequency inverter is level controlled, the DG1 accelerates directly to the given frequency of 38.2 Hz. In the status word, the fault bit is cleared with the reset and both the ready bit and the run bit are getting true. The left P key is used to switch back to text display 01 for the control word. Press the Alt key and the left P key to access marker bit 02. The bit status for the change of direction of rotation is changed by pressing the upper P key and then OK. In the subsequently selected text display 02, this is indicated in marker bit 19. Via digital input DI5, the fixed frequency 1 is pre-selected at the DG1. The DG1 now decelerates to 5 Hz. A note: a pre-selected fixed frequency has a higher priority on the DG1 frequency inverter than reference values via field bus, via analog input, or for example via internal PID controller. With low signal at digital input DI5, the DG1 accelerates again to the reference value of 38.2 Hz given by the field bus. Via the right P key, the text display 03 is pre-selected for acyclic communication. The fixed frequency 1 has to get the new value 17.6 Hz. Here, digital input DI7, which is not used by DG1, is used to trigger acyclic communication via marker bit 113. The left P key is used to switch back to text display 02 for the status word. Via digital input DI5, the fixed frequency 1 is pre-selected again on the DG1, now with the new previously set value of 17.6 Hz. With the low signal at digital input DI5, the DG1 accelerates again to the reference value of 38.2 Hz given by the field bus. Pressing the Alt key and the left P key again accesses marker bit 02, which causes a renewed change in the direction of rotation. The DG1 frequency inverter is stopped via the red stop key. This resets marker bit 01 in network 7 of the easyE4 program. Finally, the change from field bus operation to local operation is made by a low signal at digital input DI8. Thank you for your attention.